understand, the exam requires some pre-registration. The largest lecture hall in 6th holds 200 people, so that's about 1/5 of this class. So you'll want to be on that. Anyway, that's April 8th, 4 to 6 p.m. Both Professor Copsey and I will be having extra office hours, and I was just looking at my calendar. I'm not quite sure exactly how that's going to work just yet, so I will email those extra office hours to you. But I can tell you that next Monday I will be out of the country, and then the following Monday I have appointments in the morning. But I will have extra office hours throughout the week, and of course you can make an appointment. Once class lets up, then our schedules become considerably lighter. With respect to the final exam, again, I just want to assure you that Professor Copsey and I have rewritten the entire exam. The format is the same as in previous years. It's 2 out of 3 essay questions. Each of those will be worth 30%, and then there are 20 multiple choice questions, which will make up the balance of your mark. You're expected to spend about an hour on each of the 3 main sections, so an hour per essay, and then an hour on the multiple choice. The material that's covered on the exam is inclusive of the entire course, but to make it completely unhelpful to you, the emphasis is on the second half, which it should be completely unhelpful because it is on the entire course. And just to assure you that this exam has been completely rewritten, Professor Copsey and I didn't even refer to previous exams, so we didn't even remember what we had assigned in the past and rewrote the exam in its entirety. Having said that, if you have access to an old exam, and for some reason, about 900 out of 1,200 of you all seem to have access to earlier exams, if you can do that exam, or those exams, then you should be in very good shape. The scope by which we've rewritten the exam mirrors that of previous ones. Lastly, I've been encouraged by the Faculty of Arts and Science to encourage all of you to fill out the online course evaluation. I'm not sure if you've received that. In the past, we've had to do it by paper. As you can imagine, it's a logistical nightmare in a class this size. Consider yourself encouraged. So today, as I say, is the last lecture. One of the things that, just so you know that course evaluations actually matter a great deal, one of the things that students in the past have encouraged us to do actually is to talk a little bit about our own research, but to do it in a substantive way, to link it back to all of the course material and indeed to think about it in terms of political science. So today I want to talk very tangentially about my own research to give you some sense as to what it is that I do as a political scientist. Some of you might know actually that when I was your age, when I was an undergraduate, I was a double major in political science and literature. And in fact, it wasn't until my 4th year that I decided to do my PhD in political science. Actually, right until that point, I thought I might actually do a PhD in literature. So that'll give you some sense as to the kind of political science that I do and the sorts of questions that puzzle me in the type of work that I do. So one of the things that we do, of course, in political science and in politics more generally is that we tend to focus on politics during regular times, those sort of slow news days when nothing really extraordinary is happening. And in many ways that helps us in political science because in political science we look for patterns, right? And it's by looking at these patterns that then we make these larger inferences about how the world works, about how governments behave, how voters behave, and so on. In many ways for me that's kind of boring. What I'm more interested in actually are those politics in irregular times, or politics in uncertain times. And so today then, the core of the lecture will really fundamentally revolve around this idea of uncertainty. Right? Irregular times, those unusual times in which we have to deal with politics. And indeed, what I want to focus on then is how uncertainty tells us a little bit about how we deal with politics here in Canada, you yourselves as political citizens, how we deal with uncertainty in political science as a discipline, and indeed also to reveal a little bit about who we are as people. One of the ways in which we think about politics and political science is to invoke the principles of science. And in many ways we view science, and those of you who are taking science courses here at the university have a sense of this, we view science as, in many ways, the irrefutable truth. That science and the scientific method tells us something that is certain, that is an irrefutable truth. In the middle of the 19th century, actually to be exact, in the summer of 1854, there was a cholera outbreak in London. And it was an awful affair, as you can imagine. It was written about in this book called The Ghost Map, written by Stephen Johnson. How many of you have ever read this book? Or how many of you have heard of this book? It's a fantastic book. It's a fantastic book because in many ways it shows us the uncertainties of science. So in the summer of 1854, there's a cholera outbreak in London, and thousands of people are literally dying. And thousands of people are dying basically every week. And scientists at the time went at this. And the question that they were trying to answer is cholera an airborne disease or is it a waterborne disease? Because until we could figure out whether it was airborne or if it was waterborne, there was really no way in which we, or at least those in the mid-19th century in London, could figure out how to fix the problem, to stem the outbreak, as it were. So as you can see here, William Farr was a man of science, and he shared Snow's belief in the power of statistics. We're looking for patterns, right? But he also shared many assumptions with the miasma camp. And he used the number crunching of the weekly returns, was basically a weekly standard, to reinforce those beliefs. Farr thought that the single most, now he's a scientist, Farr thought that the single most reliable predictor of environmental contamination was elevation. The population living in the putrid fog that hung along the riverbanks were more likely to be seized by the cholera than those living in the rarefied air of, say, Hampstead, which, if you care, is where Morrissey lived. There are three things that this quote tells us. First, this was a disaster. The scientific establishment in London at the time had absolutely no idea how to deal with this. Thousands were dying. They had never seen this before. They thought they had never seen this before. And it was an unmitigated disaster. The second thing that we can tell from this quote is, even the day's best scientists had no idea what caused cholera. That even those scientists who were collecting the most rigorous data, using the most at the time sophisticated statistical techniques, could not determine with great certainty what was causing cholera. And third, because at the time they had no idea what was causing cholera, that there was great uncertainty surrounding the cause of cholera, they didn't know how to respond to it. They didn't know how to fix the problem. And they certainly didn't know how to fix the problem in order to mitigate future disasters. So, first clicker question. There is a very slight chance that an asteroid will collide with Earth. We know there's a very, very slight chance, leading to significant, if not complete, destruction of our Earth. To cover the costs of creating what I call a global asteroid defense force field, I am willing to accept because after all we have to pay for this, a 50% tuition increase, B, a 100% tuition increase, or a 0% tuition increase. It's not worth it, and it will never happen here or in your lifetime. So pick A, B, or C. accept a 50% tuition increase. 8% of you, nut jobs, would take 100% tuition increase. And the vast majority of you would not take a tuition increase at all. What this tells us, actually, this is a very real-world scenario if you think about it. You're confronted with these sorts of decisions all the time. What we've just described here in terms of a scenario is a very low probability scenario, but for which there would be a tremendously high impact. So in asking you the question then, because after all I'm asking how much would you be willing to spend to mitigate this risk, I'm basically asking what kind of risk is acceptable to you. And if you think about it, in many ways, politics is all about risk. Politics is about handling the things we would never expect. And learning from these things that are unexpected, and these great moments of uncertainty. For instance, we experienced the 1930s Depression. We experienced this as a moment of great uncertainty. We experienced this as a potential risk proposition in the future. And if you recall, going back to the 1930s and then into the interwar period, we as a global society learned a lot of lessons. And we said we would never let this happen again. We would never allow the banking sector to be so vulnerable. We would never allow for this kind of risk proposition to plague us again. Well, the problem, of course, is that we experienced just 3-4 years ago another global financial crisis. A financial tsunami, if you will. And of course, the question that was upon us 3-4 years ago was, how do we let this happen again? How is it possible that after the 1930s Depression, and knowing just how vulnerable the global banking sector could be, how could we have allowed this risk proposition to happen again? Well, one of the things that we use in the banking sector is this thing called the VAR model, the value at risk model. All the banks use this. During the early 1990s, JP Morgan and its quantoids inside the bank developed a mathematical model called the VAR model, the value at risk model. And basically, what this model was that it was a risk analysis model. Because after all, that's what financial institutions are dealing with all the time. They deal with financial risk. And what this risk analysis allowed us to do was it basically allowed banks to express risk as a single number. And this single number would be the risk of losing the total value of its investment. So for instance then, if a bank had a VAR, a value at risk of $100 million, with 99% confidence, it meant therefore then that there was on any given day, at any given moment, a 99% probability that that bank would not lose all $100 million. In other words, a very good probability distribution. A very likely scenario that the bank would not lose its investments. This, in many ways, was a measure of market confidence. When banks would publish every day their VARs, or when they would get together, all of the risk managers inside a large bank would get together, and they would crunch the numbers, and they would come up with a VAR, that number was a measure of market confidence. That gave the banks the confidence that on any given day, at any given moment, in all likelihood, in fact with 99% probability, that it would not lose its shirt. That it would be able to keep the value of its investments. This VAR model, though it started at JP Morgan, spread and became the standard operating procedure for all banks. In many ways, this was viewed as the corrective of the 1930s Depression. This was a way of managing risk. The thing was that basically what this allowed for then was a measurement of what banks call systemic equilibrium. And it therefore assumed what we call a normal distribution of risk. The banks would measure this every day, and by measuring the VAR every day, it would get a sense of long-term trends, it would get a sense of long-term vulnerabilities, it would get a sense of long-term confidence. The problem, however, is when you're measuring a mathematical model, or when you're using a mathematical model to measure your value at risk, how accurate is that model in measuring confidence? Your confidence in that banking sector. How accurate is that mathematical model in measuring panic? What happens when people start selling off assets? If you're playing the stock market, you know exactly how this feels. Panic can set in. And unfortunately, this mathematical model does not allow for emotional things like panic. And perhaps most importantly, what about that 1%? 99% confidence is a pretty good number. 99% confidence that your value at risk for $100 million is not at risk at all is a pretty good number. But what about that 1%? Can you prepare for that 1%? And indeed, politically speaking, what is the appropriate response? Well, I've already given you a 1% proposition, or maybe a 0.001% proposition, an asteroid destroying the Earth. Well, apparently, for the vast majority of you, that risk is not worth increasing your tuition. It's not impossible that an asteroid would destroy the Earth. It's highly improbable, but you have all decided, or at least 77% of you have decided it's not worth the risk. That you're not going to spend any more of your hard-earned tuition money to mitigate that risk. In many ways, then, politics and the real interesting stuff of politics is about uncertainty. You'll recall in our last lecture, we talk about politics all the time in terms of making decisions about the future. But if you'll recall, when we talked about climate change, it was quite clear that the future is in many ways uncertain. As James Hansen points out, and again, this is from last week's lecture, the climate is nearing tipping points. If we do not change course, we'll hand our children a situation that is out of their control. For people like Hansen, the state of the environment is at that point where we are almost past the point of no return. On the other side, of course, is Freeman Dyson from Princeton, in which he says the climate studies people who work with models always tend to overestimate the models. Dangers cannot be predicted until we know more about its causes. It's always possible Hansen could turn out to be right. Indeed, if what he says were obviously wrong, he wouldn't have achieved what he has. It's kind of a backhanded way to say, yeah, he could be right, but we don't know for sure. And if you recall, when we polled the class last week, we said, how many of you believe we're at a tipping point, and how many of you believe we're not at a tipping point? The class was virtually split down the middle. So here is a serious risk proposition. Our environment. Here's a serious issue, global climate change. And even the august class such as yours, educated people, people who think about these sorts of things all the time. 50% of you said, no, we're not at a tipping point. The other 50% of you says that we are. As I stressed last week, politics is dealing with this kind of uncertainty. We don't know for certain. We go with a hunch, we go with the best data we have available, but we don't know with great certainty. If we assume then that politics is about uncertainty, but one way in which we can think about it is what I call politics and futurity. We make decisions all the time in the context of uncertainty. You as taxpayers, your parents as taxpayers, make decisions all the time in the context of uncertainty. You as voters make decisions in the context of uncertainty, just as our policymakers. We make decisions today that will impact the future. But we're making these decisions under a cloud of uncertainty. We know, for instance, that in most industrial countries in the world right now, we live in what's called an aging society or a graying society. We know that as people live longer, that they become, over time, less economically productive. They don't work. We know that the cost of keeping old people alive is extraordinarily high. We know that this will cost our society more, as some places like Japan are reaching a point in which a good third of their population will be over the age of 65. So we have to make decisions today. But we don't really know how much this is going to cost us in the future. We don't know how much this is going to cost the taxpayer of today. And moreover, we don't know how much is appropriate. We don't know how much we as a society are willing to take to keep old people alive. We know that financial regulation is a set of decisions that we're making all the time. We're making them on Wall Street, they're making them within Congress, we're making these decisions within our own parliament. We know, for instance, that the VAR model, value at risk model that I just described for you, is flawed. We know that it isn't fail-safe. But we're faced with the question, does it need to be changed? We have to ask ourselves today, are we going to make those fundamental changes to try to insure against that risk in the future? And of course, as we all know, that fundamentally we haven't changed all that much. Every health economist will tell you, including here in Canada, that we should be investing in preventative health care. That we should be investing in public health campaigns against obesity. We should be investing in public health campaigns against alcoholism, against smoking, and so on. That we should be promoting healthy lifestyles. And every health economist will tell you that because the more preventative health care or preventative health we can invest in today means that in the future we will have fewer sick people. And it's sick people that cost the system a lot of money. But here's the problem. We know we need to invest in preventative health care, but do we know how much money is going to be saved by investing in preventative health care? If we invest $100 million in preventative health care, are we going to save $100 million in the future? We don't know. We're making decisions today in the context of uncertainty to mitigate future risks about which we know very little. We know from SARS, which we talked a little bit about last week, that even in industrial advanced countries such as Canada, that in the case of an epidemic like SARS, we don't have in our hospitals the surge capacity, the surge, the spike in the number of beds that are needed in the case of an epidemic. We know we have to change that. We know we have to invest more in the surge capacity of our hospitals, but do we know how much? Do we know how much more we should be investing in these hospitals to create hospital beds that will otherwise be empty? Again, we are making decisions today for the future about which we know, in fact, very little. Politics today is about the future, and what I'm trying to suggest to you is that the future, in many ways, is uncertain. Another way of thinking about it, then, is to think about it in terms of risk in politics. Another way of thinking about the future, then, and to think about the future and uncertainty, is to express it in terms of risk. Now, for those of you who are in economics, or those of you who are in advanced mathematics, you'll know this, that risk is effectively the probability of a certain outcome, or the improbability of a certain outcome. We don't know for certain if an outcome is going to occur, but we have some sense of that probability. So we don't know for sure. We don't know with certainty that there will be another SARS. We don't know with certainty that an asteroid is going to collide with the Earth and damage the Earth. But we do have some sense of probability. So one of the best examples of this, and indeed one of the pioneers in the modern application of risk and probability is the insurance industry. The insurance industry has been very, very good at determining for us probability, particularly life insurance. Any of you in actuarial sciences, or anyone know some really smart people in actuarial sciences? The actuarial sciences, you know, is one of the most sophisticated forms of applied mathematics. And when we think about actuarial sciences or actuarial mathematics in the insurance industry, and specifically the life insurance industry, all these people do are crunch numbers to basically tell us what the probability of, or the probability is of someone dying. They can point to you, you can give them your profile, and they can't say with certainty when you're going to die, but they'll be able to give you some sense of probability as to when you're going to die. It's a little morbid, I know, but that's essentially what a life insurance policy does. They look at you, they check you out, they ask you all sorts of questions, and then they say, yeah, we think you're going to live a pretty long time. Or they say, no, we don't think you're going to live all that long. Now, how do they know this? Well, they'll ask you questions like, do you smoke? Are you a regular drinker? Is there a history of cancer in your family? Are you obese? Do you exercise regularly? What is your diet? What is your job? What is your income? All of this data gives them some sense of probability. They don't know for sure when you're going to die, but they can say with a fair degree of confidence that if you're a non-smoker, you're not obese, you eat healthy, you have a relatively good paying job, and so on, that in all probability you will live a long time. Now you may die. You may die prematurely, but that's the risk they're willing to take. In other words, then risk is basically what we call a probability distribution. For each one of you, there is a probability distribution. As a society, there is a probability distribution as to when most of us will die. We calculate this probability distribution by looking at data. We collect lots and lots of data. So we can see that those whose family has a history of cancer has a higher likelihood of dying earlier. We know by collecting data that those who are regular long-time smokers have a higher probability of dying earlier. We know by looking at obesity statistics that those who are obese have a higher probability, not certainty, but higher probability of dying. We look at this data and we infuse it with some knowledge. We presume that certain behaviors lead to certain outcomes. That X causes Y. So the combination then of this knowledge plus this data then gives us some sense of reasonableness by which we can calculate risk. This is one of the reasons, for instance, why there is no home insurance in California, particularly those along the fault lines. Because everyone knows, scientists say that there is a high probability that there will be earthquakes there, and home insurers say that those homes that are subject to or high likelihood of earthquakes are homes that are not insurable. So you can't buy home insurance in California because of the risk probability. So this here then is the normal distribution curve. Under normal circumstances, we expect a high probability of certain outcomes. We expect, therefore, that in most cases there will be no tsunamis. We expect that in most cases that markets generally work. That in most cases there will be no new diseases, that there will be no earthquake, or in the case of Japan recently, that there will be no earthquake followed by